So acceleration, you could think of it as some kind of like a pulling effect, okay? What would happen if you are moving forward and you're being pulled forward direction? What would happen to you? You speed up, yeah. And in contrary, if you're moving forward and something or somebody is pulling you backwards even though you're moving forward, what would happen? You would slow down, right? So hopefully that can be like set into your mind as we talk about acceleration, okay? So let's think about having the correct conventional direction. We're going to think about forward direction as positive direction and backwards direction as negative direction, okay? Again, up is positive, down is negative, okay? The acceleration's direction usually does not tell you the direction of motion, okay? Only the velocity's direction will tell you the direction of motion, okay? So here is an example we have here is going forward and speeding up, okay? So initial velocity was positive 10 meters per second x hat, and then final velocity is 30 meters per second x hat over 2 seconds, okay? So the initial condition, we have an object in initial condition, right? We have an object that's going, let's say, 10 meters per second, right? So V initial is equal to 10 meters per second. And then it speeds up to 30 meters per second. Here's the final scenario, right? And delta t, right? Delta t is equal to 2 seconds. So you could think about t initial being 0 seconds and your t final is equal to 2 seconds. So you could think of it that way. All right? So, how do we calculate the acceleration of this John? Well, acceleration is simply, by definition, is equal to change in v over change in t, okay? And since change in v is simply vf, right, minus vi, right, okay, whole thing over delta t. We already know delta t is 2.0 seconds, okay? Therefore, if we plug in our values, here we have positive 30 meters per second x hat, right, minus positive 10 meters per second x hat, whole thing over 2 seconds, right? So we have now positive 20 meters per second x hat over 2 seconds, okay? Therefore, our final answer is positive 10 meters per second, which is second squared, x hat. So notice the unit for the acceleration. It is meters per second, or meters per second squared. So when we have this 10 meters per second, what that means is it will speed up 10 meters per second every second. All right? But in order to find out what your final velocity is, you need to know what your initial velocity you started from. Okay? So if you started from 10 meters per second initially, if you speed up 10 meters per second in positive direction every second, you already start with 10 meters per second in the positive direction. So 1 second later, you'll be traveling 20 meters per second. 2 seconds later, you'll be going 10 meters per second more, so you'll be going 30 meters per second, etc. Okay? Hopefully that's the simplest example we could think of. Okay? So you could think of acceleration, right? So this acceleration is read as, okay, forward change in velocity, right, of 10 meters per second every second. Okay? And that's what that positive 10 meters per second means. Now let's take a look at another example where we are going forward and slowing down. Okay? This is also known as deceleration. Okay? When things are slowing down. So, here's our initial, right? Again, our initial condition here where we're traveling at 10 meters per second in the positive direction. All right, so your V initial is equal to positive 10 meters per second, right? Of course, x hat, because we are going in the positive x direction. Now, the final velocity, this is the final condition, happens to be 5 meters per second in the positive x direction. So my VF happens to be positive 5 meters per second x hat, right? Therefore, the delta t happens to be half a second, right? So this is my delta t. So delta t is equal to 0.5 seconds. So you could think about t initial is 0 and your t final is equal to 0.5 seconds. Okay? So to calculate the acceleration now, my acceleration again is equal to, right, delta v over delta t, which is equal to, right, vf minus vi, right, whole thing over, right, delta t, right. Therefore, VF is positive 5 meters per second x hat minus, right, positive 10 meters per second x hat, whole thing over 0.5 seconds. So if you do this, notice you'll get negative 5 meters per second x hat over 0.5, right? This comes out to negative 10 meters per second x hat. Okay? This means is backwards change in velocity, right? This is the backwards. Of 10 meters per second every second. Okay? So if you're going forward, you're slowing down 10 meters per second every second. So what's going to happen eventually if you keep doing this for like 3 seconds? Eventually going to stop instantaneously, and then what? Start going backwards. Accelerating backwards. Yeah. Yeah, that can happen. So this is very important, the time frame. Right? The time frame is very important. Very good. Let's take a look at one more. Going forward, stopping, then going backwards. Both deceleration and acceleration. Okay? So here, this is tricky one. Right? This one is a tricky one. So here, my initial velocity happens to be positive 20 meters per second. Right? So here, my initial condition is positive 20 meters per second. I'm not going to draw this like to scale. I'm just drawing it out so you can visualize it. However, your final scenario happens to be negative 80 meters per second, right? So V final happens to be negative 80 meters per second x hat. And of course your delta t is 5 seconds, right? So your initial t is 0 seconds, right? Your t final is 5 seconds, so your delta t is equal to, right, 5 minus 0, which is 5 seconds. Okay? So we'll go with that. Now let's find acceleration for this. Okay? So here, my acceleration is equal to simply, right, V final minus the V initial, right? Whole thing over delta t, right? Therefore, my V final happens to be negative 80 meters per second x hat, God bless you, minus positive 20 meters per second x hat, whole thing over 5 seconds. Okay? So if I work this out, I'm going to get 80 minus 20 is negative 100 meters per second x hat, whole thing over 5 seconds, which is negative 20 meters per second x hat. So, what's happening? Initially, I'm going positive direction for 20 meters per second, but I have a pulling experience of negative 20 meters per second every second. So what's going to happen after 1 second? What would happen after 1 second of pulling 20 meters per second if I'm starting out at positive 20? If I'm being pulled 20 meters per second in the negative direction. Huh? You would stop instantaneously. So it's going to go this way, 20 meters per second, slow down, slows down, slows down, slows down, stop instantaneously. And then you'll be accelerating in the negative direction, 20 meters per second every second. So 2 seconds later, you'll be going negative 20 meters per second. 3 seconds later, negative 40 meters per second, and so on. Okay? So here, right, if acceleration of negative 20 meters per second remains present, right, it will first slow down, going in positive direction, then stop at t is equal to 1 second. Then it speeds up in the negative direction (20 meters per second every second) backwards. All right. Hopefully that explains what happened. All right. All right. So I'm going to give you an opportunity to check your understanding on page 8. So see if you can try page 8. And then we'll go over the answers on page 8. Okay? And I'll give you page 9. All right? And yeah, just page 9 for homework. All right? So let's see if we can try page 8 right now. I'll pause it here. All right, welcome back. Let's go over this very quickly. All right, so here again, if we were to look at the initial condition, we were going backwards 15 meters per second. Okay, so we're going this way, right? Initial condition. So V initial is equal to negative 15 meters per second exit. Okay, and then for the final condition, right, so this is the initial, and then for final, we're going still in the negative direction, right? 45 meters per second. So this is your V final, which is negative 45 meters per second x hat, and your delta t is 3 seconds, right? So your t initial is equal to 0, your t final is equal to 3 seconds, so your delta t is equal to 3 seconds. Okay, so acceleration, of course, is equal to, right, change in velocity, so v final minus the v initial over delta t. Therefore, your acceleration should come out to negative 45 meters per second x hat minus negative 15 meters per second x hat, whole thing over 3 seconds, and this should come out to 30 over 3, negative 30 meters per second x hat over 3 seconds, therefore negative 10 meters per second x hat. Alright? Alright. This means it is speeding up in the negative directions. Okay? So this means it is speeding up in the negative direction meters per second every second. Okay? Alright, next we're going to go backwards and we're going to slow down. Okay? So acceleration and deceleration. So initially we are traveling at negative 60 meters per second. So here, again, I'm not drawing these to scale, I'm just drawing it out to visualize it. So V initial is negative 60 meters per second x hat. Okay, so this is our initial condition. And our final condition happens to be negative 20. Right? So our V final happens to be negative 20 meters per second x hat. And of course our delta t is equal to 2.0 seconds, right? So t final is 2 seconds, t initial is equal to 0 seconds, and so on. So our acceleration is equal to simply Vf minus Vi over delta t. Therefore, my acceleration is equal to negative 20 meters per second x hat minus negative 60 meters per second x hat, whole thing over 2.0 seconds. Therefore, this becomes positive 40 meters per second x hat over 2 seconds, right? Therefore, my acceleration is positive 20 meters per second x hat as my acceleration. Okay? So this means it's slowing down, going backwards. Right? Okay? Last one. Last one is going backwards, stopping, then going forward. So we're going to go this way, and then go stop, and then it's going to go that way. Alright? So here, our initial, again, is negative 30 meters per second going this direction. Right? So initial, so our V initial is equal to negative 30 meters per second x hat. It's our initial condition, and our t initial is 0, right? And then for final, it's going in the positive direction. So you must have stopped instantaneously somewhere and switched directions, right? So V final is equal to positive 30 meters per second x hat. And our delta t, of course, right, t final is equal to 6 seconds. Okay, so this is our delta t. So my delta t is equal to 6 seconds. And this, of course, is our final condition. Therefore, my acceleration is equal to, right, Vf minus Vi over delta t. Therefore, my Vf is positive 30 meters per second x hat minus negative 30 meters per second x hat. So negative makes it positive, right? Whole thing over 6 seconds. And therefore, this becomes positive 60 meters per second x hat over 6 seconds, which gives you positive 10 meters per second x hat. So first is going backwards. Then stops instantaneously, right? Then speeds up positive 10 meters per second every second going forward. All right. So I'll stop there for today, and I will post this video on Schoology if you want to watch it again, just to revisit if you want to. And you can do page 9 for your homework, okay? And then we'll go over that tomorrow. So give it a shot. You've got plenty of time to do it and finish it today.